Adil Berkay, Aykokul, Apik, Banu, Begimay, Canan Ayhan, Feyz Yasin, Hamza, Kurnaz Han. Good morning to all of you.
Good morning, Mr.
Good morning, Miss.
Good morning. Nice to
Good
meet you.
morning.
Good morning.
Can we look through the questions, exam questions? I think there might be some maybe mistake.
Oh no.
Can we check? It's interesting.
Let Azamat do it in the practical sessions.
Okay.
Dr. Azamat, what do you think?
Yeah, we can go through the questions during the practical session.
Thank you.
Okay, thank you.
Thank you. Yes, there might be always mistakes. If there is a mistake, we will compensate it. Don't worry.
Yeah.
Okay. Today we will discuss errors in hypothesis testing. Let me see the list. Errors in hypothesis testing, and then we will go over to the individual hypothesis tests. Numerical data, one group. Which test do we do? Anybody remembers?
One simple t-test.
One sample t-test. Good. Or the sign test. Numerical data, two related groups.
To related pair t-test
Pair
or
t-test.
Wilcoxon test.
Wilcoxon.
Parametrical and non-parametric.
Yes. Independent groups.
Independent unpaired t-test.
Unpaired t-test or student t-test.
Man with you.
Oh yeah, thank you. The alternative is the man with me. And then we have the numerical data more than two independent.
ANOVA.
ANOVA, one way ANOVA.
What was the alternative of ANOVA?
Coxal
Chi-square.
test.
Chi-square, Canan, thank you. Not chi-square, who said chi-square? It's not chi-square.
It's for categorical data.
Yeah,
More than two groups.
the alternative of ANOVA, non-parametric alternative of ANOVA is listening. I'm listening. Apik, maybe you know it. Maya Ibrahim. Ammar Rafi. Okay, Jana. It's not chi-square.
It's Kruskal Wallis. But you
Kruskal
might
Wallis.
said it actually.
When she said it, I couldn't hear it. Sorry. And then
Yes,
we have,
I said.
sorry, I heard chi-square. Okay, then we have the categorical data. If they are related, the categorical data, we may do the McNamara or otherwise the chi-square. So today I will start with the errors in hypothesis tests, and that's a really interesting topic, I think. I like it very much because it's also a bit about the philosophy of statistics. When we speak about errors, does it mean that there are errors really in statistics?
Might be.
There might be, of course, there might be. Let us go to the PubMed. To PubMed, and read a paper. Search about what? I always search about diabetes because it is so common. And pathophysiology, evidence complications in India. Okay. Let us see this one. Is it full text available? you should have something full text available. Free full text. Okay, the association between diabetes mellitus and depression. This is available full text. You already know that in any paper, you have the title, the authors. This is also in your reports, in your practical sessions. You have a title, the authors, then an abstract should be there, keywords, and then the article starts with an introduction. Just reminding you about the structures of a paper. Introduction. This is a review paper, sorry. We should have a research paper. You find the research paper, sorry, go back. Definition, classification, diagnosis. Okay, here is something, sex and gender differences in risk pathophysiology. See the full text. Okay, again, we have the title, the authors, the abstract. Then the introduction. I hope this is the research. It seems like another review. That didn't happen to me before. Epidemiology. Come on. Let's make it a clinical randomized controlled trial. Now there is no other chance. There must be methods. Okay. Oh. Abstract methods, results, conclusions. Okay. I want to read the methods about statistics. Did they mention about statistics? The outcomes they mentioned here. Statistical analysis they mentioned here. As you see in detail. They made an ANOVA test, Wilcoxon rank sum test. These are all familiar to you, you see. And they have given their results with 95% confidence interval. You already are familiar with the 95% confidence interval, aren't you? So if you give a 95% confidence interval, 95, let me repeat this issue about the 95% confidence interval. What was the 95% confidence interval? 95% confidence interval.
Internal estimate?
Yeah, there was an interval estimate. Very good. We make a point estimates and then we give an interval estimates. And the formula for 95% confidence interval, if we have a numerical data, was
mu mean
plus minus
plus minus 1.96. If I'm not mistaken. Yes, 96.
multiplied by
Standard error.
standard error of the mean. Very good. So if I have this formula, very simple formula, I can calculate for numerical data the 95% confidence interval. And I had mentioned to you, if you have, for example, the weight of males, two groups, males and females, let's say, the males are weighing, let's say, 70 kg, and the females are 55 kg. Okay. So this is the mean values. And then you give the 95% confidence interval. The difference is here. How much? 15 kilogram. 15 kilogram difference. And then I give you the 95% confidence interval, and it's, let's say, between 10 and 20. The 95%. It's usually given by the brackets, square brackets. 10 to 20. That means if you go and repeat this experiment, measure the weight of the males and females, in 95% of the of the instances, you will have a difference of 10 or a maximum difference of 20. But this is in 95% of the cases. There are 5%. In 5% of the cases, it may be more than 20 or less than 10. That means there is by starting the study in the beginning, I decide that I have the possibility of making errors. I have the possibility of making a wrong decision. And these wrong decisions, logically, they can be of two types. They call it the type 1 error or alpha error, or the type 2 error, the beta error. Type 1 and type 2, I have to explain you further. But here is a nice table in the book explaining this further. There is a truth about the H null. Always we have the H null. We have the H null, always. H null was structured as negative. For example, there is no difference, no significant difference. In what? In something between medication A and medication B in decreasing blood pressure, systolic blood pressure. Okay. So this is my hypothesis. My starting point is that there is no difference between. And after collecting the data and making the statistical analysis, t-test, ANOVA, Kruskal-Wallis, whatever I do, I come on a conclusion. I decide on something. I either accept the H null or I reject it. Then I have this 2 by 2 table. Okay. Here, draw this 2 by 2 table. Yeah, 2 by 2 table. At the end, there is a decision. I have a decision. At the end of the study, I make a decision. So I have a decision at the end, let's say, decision. And there is a truth. Who knows the truth? Who knows the truth, whether there is a difference between drug A and drug B?
Yes. Like,
Well, nobody knows it. Allah knows it. We don't know. We don't know. The reality, it is very difficult to know the reality. To some extent, we know it, but we cannot be 100% sure on anything. Can you be 100% sure on anything? No, there is nothing like 100% in statistics. We have always a possibility of a mistake, of a possibility that the alternative is true. It has to be. So, in order to make it easier for you to understand, I use an analogy. I use the analogy of a court. I don't like courts. Of a court. Okay. you know, in a court, there is a judge who decides, right? There is a attorney, or the advocate. Let's say this is a state attorney. What does the state attorney say? What is his claim in a court? Do you know how the court works?
Not so much.
Not so much. Okay, there is an accusation. Let's say you are the judge and I am the one accused. There is an accused and there is an advocate, and there is the accused. Okay. Imagine I am the accused. They bring me to you. You are the judge. They bring me to you, and I am accused of stealing something. I am accused of stealing the pencil of Abdul Basit. Okay. I have an advocate. I decide to have somebody who defends me, and he claims what? He says he didn't do it. What is your age null? The judge has an age null. What is your age null? Can you formulate the age null of your of the judge? It is Zakaria is not guilty. Always negative, no significant difference. Not guilty. This should be the starting point, the age null of the judge of the court at the beginning. What is the advocate saying? He's defending this age null. He says, yes, age null is true. The reality is age null should be accepted. It is true. What is the state attorney say? There is another guy, another person in the room. He's called the state attorney. He says, no, he did this. He did steal the pencil of Abdul Basit. Put him into prison.
It means he is guilty.
Yeah, he says he's guilty. So the state attorney is defending that he is guilty. The advocate of the person, he says he is not guilty. He's accept age null, and the judge has to give a decision. It's very similar to what we are doing in science, in research. Also in research, we have an age null. We have to either reject it or accept it. So reject age null or accept age null. This is the decision of the judge. You understanding me? You are the judge. Imagine that. Imagine you are in a room, in a courtroom, and somebody is brought to you, allegedly of doing some crime, allegedly of stealing something or doing something. This is me. Imagine it, and you have to make a decision. You do your decision on what? Based on what? Based on the evidence. You need evidence. You collect, you ask for evidence. You ask the state attorney, can you show me evidence that he did it? And the state attorney shows you camera records or witnesses. He calls witnesses to witness about what has been done, or other kinds of evidence. After having seen the evidence, you decide to reject the age null. Age null was, I am not guilty. If you reject it, what do? You put me into prison. Right?
Yes.
Okay. But there is a truth. The truth says age null is true or age null is false. Age null true or age null false. If age null is true, it means I am not guilty. And this truth is known by me. Who knows I have stolen the pencil of Abdul Basit or not? Allah knows it, and I know it. If there is somebody who has surely seen it, maybe he knows it, but it is rarely possible that the truth is known by the researchers in a research. We usually don't know. We just try to guess the truth. So, if the age null is true, if the age null is true, this is type 1 error. Huh? Type 1, or alpha error. If age null is true, I am not guilty. The reality is I am not guilty. I know it. Allah knows it. I swear I didn't do it. But you are the judge, you reject it. You say put him into prison. This we call the alpha error or the type 1 error. Is it possible to do an alpha error? Unfortunately, yes. Also in the court it is possible. As it is in the court, it is also possible in scientific research to make an alpha error. But we have a tolerance for alpha error, a limit, a threshold. Do you know the p-value? How much should be the p-value to be significant? The significance level for p-level, the threshold? It was
0.01. Or
Thank you. It can be 0.01, yes, but usually we accept it as
0.5.
0.5. Yeah, it can be. Who said 0.01? He is also correct. You decide it on in the beginning of your study. You put the threshold at the beginning of any study. You decide you will have 95% confidence interval, as it is here, or you may say I want to have 99% confidence interval. This is up to the researcher, but it is arbitrary for scientific studies, current scientific studies, that we have a p-value, a threshold of 5%. So that means we have actually we have a tolerance for the alpha error, which is 5%. 5%. Okay, so this is 5%. Very important. We have 5% tolerance for the alpha error. If you, the reality is I didn't do it. I am innocent, and you accept H null. You are the judge. You accept H null. This is a correct decision, huh? Correct. Should I say correct here? I make a check mark. Correct decision. And congratulations, you did it correct. Of course, if you calculate the percentages, this will be 95% tolerance to this, and total is 100%. The other possibility of making an error is the reality is H null is false. I know it, but I don't say it openly, frankly. I did it. I have stolen the pencil. I am guilty. But you, judge, you accept H null. You say, let him go. He is not guilty. This we call the type 2 error or beta error. And here is a trick which I didn't mention you so far. This is some new information to you probably. The tolerance for type 2 error is 20%. The tolerance for type 2 error is 20%. Okay, you see, for an alpha error, we have a 5% tolerance. The p-value is less than 0.05. We reject the null hypothesis. We claim that there is a significant difference. And for beta error, we have the tolerance limit is 20%. Okay.
What does this? Yeah, what does this tolerance like? What does this percentages mean? Why?
The percentage means And let me ask you. I wish I could do a survey right now in the class among your students. Let me ask you. You are the judge, Banu. You are the judge. Talk to me. You are the judge, and I am the accused person, the possible criminal, and you. I was brought to you into the court with the accusation of stealing something. You collect the evidence. You have collected evidence, but the evidence is not enough. You are not able to decide. You are on a state where you're not sure whether you should say put him to prison or let him go. You don't have enough evidence. What would you do? Tell me what your heart says to you. Because
Move the court to another date, and we have to collect evidence. So that...
Okay, that's the best way. The best way is to collect enough evidence. Thank you. That is exactly the thing we should do. But even if you collect enough more evidence, sometimes there is no evidence. Nobody has seen me to do it. Or there is only one witness, but he's not sure. You're asking, are you sure? Are you sure? Have you seen him? Yeah, he says. He stretches his hand, but stretching my hand doesn't mean that I have taken the pencil. Maybe I just touched it and left it there. Somebody else has taken it. So there is the best way is, I'm asking you, if there is not more evidence, you cannot collect more evidence. You don't have more evidence, and you have to decide. The court continues days, months, years. How long you will continue? At the end, you are the judge. You must give a decision, and you are not sure. If you are sure, okay, you will say he's guilty or he's not guilty. Let him go. But if you are not sure, your heart has to say, has to weigh on something. You have to give a decision, difficult decision sometimes. Let him go or put him into prison. And if you are not sure, what would your heart tell you to do?
If there's some like evidence that he did it, and even though it's small, I have to put him in prison.
Okay, you prefer to put him into prison.
Yeah.
Even though the evidence is low, you don't have sufficient evidence, but you have a suspicion. You just have a suspicion. You put him into prison, Banu. That's what I hear. Okay, thank you for giving me this opportunity to say this. I am happy that to know that the world civilization, the world people are not thinking like you. Otherwise, everybody would be in prison. I have been in prison for some time, and I don't know. I know it's not a good thing. The rule in the court is until it is proved everybody is unguilty, everybody is innocent. The rule of innocence, you know that? Anybody has a relative who is a judge or who is attorney, advocate?
Yes, sir.
Raza, okay. Can you answer this question? What would be your preference?
Someone is suspicious of any activity.
Mm-hmm.
Sir, we can't put him in prison because there is there is a error. Maybe he is not.
Mm-hmm. So you would prefer to you agree with Banu to put the person into prison if you have even if you don't have enough evidence?
No, sir, we can't put him in the prison because we don't have proper evidence. We are not 100% sure.
Okay, unless you have sufficient evidence, you must say let him go. That's
Yes,
the rule
sir.
that's the rule in the court, Banu. That's the rule in the court. Unless you don't have sufficient evidence, even you have suspect. With suspect, nobody can be accused. Nobody can be decided to be guilty. Tamam. The rule is always the accused benefits from the uncertainty. If there is uncertainty, the accused person benefits from that, not the judge.
But Mr. We can look at the advocates' words, how they
Yeah, they have to bring evidence to you. Both the attorney, state attorney, and the advocate, both of them have to bring evidence. You ask for more evidence, but at the end there is not enough evidence. If there is enough evidence, you make your decision, and I congratulate to you. But if there is not enough evidence, that's what I am asking you. You're not sure. You cannot put a person into prison if you are not sure. Our tolerance to this is very low. This is also.
Is there, sorry. I think there are some cells that not exactly in the prison, but outside the prison. It's like in some kind of a building that related to the police people, you know, not exactly in the prison. I mean, to keep him until we find enough evidence.
But this is under custody. This they call the custody, huh? Gözaltı, custody. Okay, but this you cannot keep a person for. It is also prison, you know. You can keep a person under custody for a few days, not for months. A few days, you can keep him there, and you can collect evidence during that time. But at the end, you must give a decision. Anyways, my friends, the rule in social life is, if I make this experiment usually in a class where I have lots of students and we are face to face, and I observe that most of the students decide, fortunately, that if there is not enough evidence, I prefer to let him go. And I don't prefer to put an innocent person into prison. Instead, I prefer to let a guilty person go. This is the sense, the feeling, the subjective behavior of the human being. In a social life also. Instead of making an alpha error, we prefer to make a beta error. Therefore, our tolerance for the beta error is higher. We have a 20% tolerance to make a beta error. What does it mean, a beta error? Let a guilty person go. Ejnul is false. He is guilty. Reality is he is guilty, but we don't know it. We are the judge in the court. We have to make a decision. And if you don't have enough evidence, we prefer to make a beta error, 20%. The possibility, the tolerance for the alpha error, on the other hand, is very low. It is 5%. Why 5%? Why 20%? Is there a rule for this? No rule for this. This is arbitrary. You know what arbitrary means? Arbitrary. For those who know Turkish, it is kabul, arbitrary. You just accept this. This is the usual acceptance of the scholars, scientists. They accept it as 5%. In the judge, I'm not sure in the court whether there is a 5% or 20% rule, but there is also a preference to let a guilty person go if you are not sure, if you're not 100%, if you are not pretty much sure about his situation. So here we have an 80% chance, and here we have a 95% chance. Okay, 95% of correct decision. This 80% we call the power of the study. If you read the book, you will come up with something called the power. The power of a study must be how much? It must be the minimum acceptable level is 80%. Our tolerance, minimum power should be 80%. Now look here, please. If you increase the beta error, what will happen with the power? If you increase the beta error, the power will decrease. If you have 30%, then this will be 70%. because it has to be 100. This also has to be 100. So there is an inverse relationship. What will happen with this? We don't call the power, by the way, although the possibility of accepting H null when H null is true. So accepting H null when accept is true means what? Not guilty. The truth is he is not guilty, and you say I accept H null. The power of the study is to say innocent to a person who is innocent. The power of a judge is to tell somebody who is innocent that he is innocent. It is not to put somebody into prison who is who has done the crime. Okay. So, anyways, I got a bit confused. Okay, I mentioned that the power is 80%. So, there are factors who affect the power. Factors affecting power. What is related with power? Number one, affecting the power is the evidence. Evidence. The N. In statistics, we call this the N, the sample size, how many people you have. Number two, affecting power is what? Your tolerance for the alpha error, of course. Alpha error. Please tell me how alpha error will affect power. If you try to decrease the alpha error, if you try not to make an alpha error, what will happen with the beta error? If you are a judge who claims that he will not let any guilty person go,
beta error will increase?
Yes, these are also inverse relationship. They have inverse relationship. If you increase the alpha error, if you decrease the alpha error, you will increase the beta error. So the power will decrease. So inverse relationship. We have an inverse relationship between alpha error and the power. The third factor affecting the power is the variability. Variation. This we call the standard deviation in statistics, the variation between the cases. For the court, I can explain you this variation. Imagine a person is brought to you from a village where everybody is innocent. Melek, all are angels, no guilty person, 100 years, no crime has done there. Everybody is the same. Or if somebody brought to you from this village where everybody is the same, and the state attorney claims that he did a crime, it is easy for you to reject it, and you say no. Then from this village, there will be nobody guilty. Or the reverse. If there is a village with so many criminals, all the inhabitants of the village are criminals. There is no standard deviation, no variation. All are the same, all are criminals. Then again, your decision will be easy. But if there is a village with a lot of variation, there are people who are angels, who never applied a crime in their life, and there are, together with these people, there are also others who do a lot of crimes, who have a lot of files, admitting some crimes in the past. So if somebody is coming from this kind of village with a lot of variability, it will be difficult for a judge to make a decision. Therefore, if variation is high, it is decreasing the power. It is decreasing the power. It is decreasing the power. If you increase the variation, then power will decrease. If you increase alpha error, if you increase the alpha error, power will increase. The reverse. If you increase alpha error, power will increase. If you increase sample size, power will increase. Okay. Number four. What else? I have to check the book, not to forget it. Significance levels. Yeah, the effect of interest. Anything else? I forgot. Sample size. I mentioned significance level. I mentioned variability. I mentioned the effect of interest. Effect of interest is something you're hearing first time probably. Effect of interest. What is this? This is your level of trying to find the differences, the degree of what kind of, how much sensitive you are in giving your decisions. Because, again, trying to explain from the court example, there are some judges who are not so sensitive when giving a decision, who don't want to know all the details. For them, it is enough to have some kind of evidence. But there are some others, they want to know all the details. They want to know if you tell them Zakaria has stolen the pencil of Abdul Basit, he will ask you, okay, have you seen it? You say, yes, I have seen it. I have also camera records. He will ask, okay, is there in the camera records also sound? If you say, yes, the sound is also there, he's speaking. And then he will ask, okay, tell me what date it was. Tell me what time it was. Tell me what kind of clothes he was wearing when he was there. So he will ask so many other details, which is difficult to get. In this case, of course, if you look for the too much details, if you have a low effect of interest, it means low effect of interest means you want lots of details. You are behind too much details. If you are looking for details, of course, it will be difficult to have a high power. So if you decrease the effect of interest, you will decrease the power. It has an inverse relationship. Let us read it also from the book. The power of the test is greater for large effect size. So if you have a large effect size, the power will be higher. A hypothesis test thus has a greater chance of detecting a large real effect than a small one. Okay, so if you have an effect of interest, the effect size is large, you will have a higher power to decide. But if you are somebody who wants to know all the details, you have a small effect size, then your power, you need much more evidence. You have to increase the evidence. There is a nice application for this before closing. P-face. Where's P-face? Here it is. There is a nice application developed for this to calculate the power. I just want to make you a demonstration before closing this session. But before closing, we will go and see also. Let us assume we want to make a two-sample t-test. Two-sample t-test means we want to compare a numerical data between two groups. numerical data between two groups. Okay, numerical data between two groups. You know this. So there is the standard deviations of the different groups, standard deviations. To make it easier for you to understand, my example will be blood pressure, systolic blood pressure. I measured the systolic blood pressure, okay? Systolic blood pressure, let's say, SPP, systolic blood pressure. It is in one group, it is 140, the mean value. In the other group, it is 130. And the standard deviation is 10, let's say. Okay, so I have a sigma, a standard deviation of 10. Let me write in here 10. 10. I have a standard deviation of 10. Okay. The standard deviation is 10. I have also the true difference of means. How much difference in blood pressure between the two groups? How much difference is clinically important? If this is the effect of interest, you see, the true difference means is equal to effect of interest. How much difference? If you are looking for 0.5, very small differences between the blood pressures, of course, I need a high sample size to reach a significant power. You see the power here is now 0.05, 5%, very low power. This is not acceptable. We need a power of at least 80%. Now I'm increasing my sample size. As I increase my sample size, my power will increase. You see, from 25, I made it to 400, and my power has become now 11%. Still not enough. I need 400 people to have 400 plus 420, 420 plus 420 to reach a power of 11%. It is still not enough for me to conduct this study. But if I increase my true difference of means, you see, if I make it instead of 0 point something, if I make it, let's say, 5 millimeter mercury, I will have a very high power. Power becomes 100%. So then I can decrease my sample size again. I can decrease the sample size, you see. Now let me ask you, it's your turn to decide. I have here in the equation, you see, I have the sample size. This is the sample size, and I have alpha error. I have the variation, the standard deviation, variation, the sigma here, and the effect of interest. This is the effect of, here is the effect of interest. Here, it is now 5. Now, let me ask you, instead of making alpha 0.5, if I make it 0.01, what will happen with power?
It will increase.
Look at here. If I increase, I didn't increase alpha error, I decreased it. It was 5, I made it 1. What will happen with power? Think once more.
It will decrease.
Power will decrease. Why it will decrease? Look. Alpha error and beta error were disproportionate. If one is increasing, the other one was decreasing. So if you decrease alpha error, you will increase beta error. If the beta error is high, it means you will have lower power. Okay, let me click enter now here. Look, we have 97% power here. From 90% to 7%. I clicked enter. From 97, 79, sorry. It was 79 before? Yes, 79, 97%. It became If I make it 1%, the alpha error, it becomes 90%. It has decreased. When I decrease the alpha error, I decrease the power. If I make it instead of 0.1, I make it 5%. 5%. I have 97% power to conduct this. What will happen if my standard deviation is low? If I decrease the standard deviation, instead of 10, I make it 9. What will happen to my power? If I have lower standard deviation, it means that if you have lower standard deviation, you will have your power will increase because the standard deviation and power are also inverse. They have an inverse relationship. Instead of 10, if I make it 9, you see my power has increased again to 99%. But since for me to conduct any study, it is arbitrary to have 80% power. I don't need 120 people. What can I do? I can decrease my sample size. And when I decrease my sample size, also my power will decrease, of course. But it is acceptable to have 80%. Therefore, you see, instead of 100 and something, I can have 50 and 50 people, and this is enough. 100 people will be enough to conduct this study with a power of 81%. So this is an app. You can find it in the internet. Just search for Rusland. Here is the name of this person. Let me open it again. Go and exercise with it. By Rus P-face, they call it. Russell Land or Russ Land. This is the name of the person who developed this application. It is very nice and demonstrative, I think. Okay. Yeah. Let us look back to the book again and see whether we forgot to mention something. One more issue today to mention here. One more issue. But first I have to make sure you understood it. You understood type 1 and type 2 errors. Did you understand the concept? In any statistical analysis, there is a possibility to make two types of errors, either type 1 or type 2. The type 1 we call the alpha error, type 2 we call the beta error. It is arbitrary, it is accepted generally that the alpha error can be maximum 5% and the beta error can be maximum 20%. And the power of any study is to say innocent to a person who is really innocent. It is not to put a person into prison who is guilty. It is, the power is to say that, to reject age null when it is false. The power. And these are the four factors which are affecting the power of any study. The evidence, if you want to have low type 2 error, or if you want to increase your power, you have to do what? You have to increase your sample size. You have to increase the evidence. You have to collect more evidence. If you don't want to, this is the maximum tolerance, you know. Nobody is telling you to make 20% error, alpha error, a beta error, or 5% alpha error. You can decrease your alpha error to 1% or even less. But then you have to collect, of course, more evidence. You have to increase the sample size. If you increase your alpha error, this is disproportionate with the beta error. So if you increase your alpha error, you will decrease the beta error, and that will increase the power, of course. If you have a high variation, your power will decrease. If you have low variation, your power will increase. And the effect of interest is the amount of difference you are going to catch. You want to, the amount of difference you want to study. If you want to study, if you want to search large amount of difference, that's easy to find. But if you are behind small differences, that requires much more sample size. Or if you look for small differences, your power will decrease. And this is all related with each other, as you have seen in the demonstration with this P-phase application. Okay. The last thing in this session I have to tell you is about the multiple hypothesis testing. Multiple hypothesis. If you do more than one test, each time your alpha error, type 1 error, will increase, and it increases dramatically because probably in one of the previous sessions I mentioned to you, I don't remember exactly, but please remind me if I did or if I didn't. Oops. Yes. So the multiple hypothesis testing, Let's say I have the first H null 1, and there is an alpha error. This is the alpha error. The alpha error is 5%. I have another H null 1, H null 2 then. I do another hypothesis in my study. I have again another 5% alpha error rate. So if I continue to have multiple hypotheses, let's say 10 hypotheses, what will happen to my alpha error? It will increase. How it will increase? We will apply the rule of addition. The rule of addition. The probability rule. You remember the probability rules? Probability.
This is addition is or rule?
The rule of addition says if you have two probabilities and you ask either 1 or 2 can be happening, it will be 5 plus 5%. This will be 10%. The rule of addition. If you have multiple hypotheses, if you have 10 hypotheses, can you imagine what will happen to your probability? It will be 5 plus 5 plus 5 plus 5. So 50%. 50%. It will be, if you have 10 tests, approximately 50, not exactly 50, but this is approximately 50. Why not exactly 50? Because this is the probability A, and this is the probability B, but they can also be together. If I add them together, A plus B, this is 5%, this is 5%, total is 10%, but there is also a proportion where we have A multiplied by B, A by B, the intersection. So therefore, this is not exactly, but this intersection is very small. You see, 5% multiplied by 5% is very low. Therefore, the possibility will be almost 50%. And if you, why I believe that is important for you as medical students, because if you order tests, if you order laboratory tests in medicine, if you order laboratory tests, each of your laboratory tests has a probability of bringing false positive or false negative results. It is even higher than 5%, sometimes 10%. Approximately 10% of your tests will be wrong if you measure something if you, okay, for tests such as AIDS, it is the probability of bringing a false result is very low. But imagine you are doing a test for corona. What is the possibility of having a false negative? It is 10%. The corona tests, they are not 100% sensitive and specific. So if you order multiple tests in a patient, if you order hemoglobin, hematocrit, then blood sodium, blood potassium, blood glucose, and so on and so on. If you order 10 tests, it means you have at least one of them will be false positive or false negative. Therefore, this rule applies also, this multiple hypothesis testing rule applies also to your clinical practice when you become a medical doctor. If you increase the number of tests, if you increase the number of hypotheses, your type 1 error rate, also type 2 error rate increases, but we are afraid of type 1 error rate especially. We are concerned more with the type 1 error, alpha error. It will increase dramatically. Therefore, we strongly suggest you to not to make too many hypothesis testing. Also, we strongly suggest you not to order too many tests in a patient. Order as many tests as necessary, not too many. Okay, I have exceeded my time, I know it. I have exceeded my time, but this was, I believe, an important and to me also interesting topic in statistics, in biostatistics, errors. Just let me mention some, I don't want to give a break, just 5 minutes I want to mention about this numerical data, single group, and then let you go. Is it okay, Dr. Azamat? I know you might be tired, but I will not give too much details about the numerical data single group. As you already know, when I say numerical data single group, I measured a numerical, collected numerical data such as blood pressure, blood glucose, height, weight, and any numerical data. And I collected in a single group. In one group, I want to compare, that means I want to compare it with a known probability, known mean, known population mean. So we are interested in whether the average of any variable takes a particular value. What I mean by particular value, that is something we know. I measured the blood pressure of you students, and I want to see if it is more or less significantly different from 140. This is a value I know. 140 is the limit for hypertension for systolic blood pressure. If I measured your blood glucose values in your class, and I want to see, is it significantly different than 110, 126? These are there is some numbers measured from the population, or some numbers we know we want to compare it, some known mean values. In this case, the test I have to do is the one sample t-test. One sample t-test has these parametric tests. All the parametric tests have some assumptions. You have to meet these assumptions to conduct these parametrical tests. And in all parametric tests, the assumptions, the two assumptions you will see is, one is in the population of interest, in the population, the variable should be normally distributed. Normally distributed. The second assumption, this is assumption one, and the second assumption is you have to have a reasonable sample size. So enough sample size and normal distribution are the two assumptions of this test. If I ask you what are the assumptions of a parametric test or of the one sample t-test, you should say it is normal distribution and sample size, reasonable sample size. It is a very simple formula. You don't need to memorize the formula, but I want to show you that what is included in the formula. Your mean, the mean of your population, the mean of this Alatu students, minus the population mean or the mean you want to compare it against, divided by, what was this formula for? Standard deviation divided by square root n. This was the standard error of the mean. You see, if you know the standard error of the mean and the means of, you measured the means of your population, it is very easy to conduct we calculate a t value. If your assumptions are not satisfied, what means if assumptions not satisfied? If the assumptions were normal distributions and sample size, enough sample size. So if you don't have enough sample size, or it is not normal distribution, it is not normally distributing, then we have to do the sign test or the Wilcoxon sign rank test. But sign test, if you remember sign test, it is enough. Okay, so the sign test, the rationale for the sign test is it is using the rank of the participants. It is calculating the rank, if it is positive or negative, if it is higher or greater than the mean or lower than, smaller than the mean. That's very simple tests. The only thing I want you to remember is all the non-parametric tests. All the non-parametric tests are using the non-parametric tests. Non-parametric. They use the rank. The rank. Positive, negative, high, low. They use the rank to calculate. You can go and read this section here, how it is calculated. It is using the median, you see, the median of the population, not the mean. The median is found by ranking, by putting them into an order. If you have a parametric test, on the other hand, parametric tests use what to calculate? Parametric use the mean and standard deviation. The mean and standard deviation. Okay, so this is the general rule I want you to remember. If you have a non-parametric test, we don't have anything to do with the mean or standard deviation. You just use the rank, the median. The median. Okay, that is enough, I think. Everybody's tired. I'm tired as well. Okay. Any questions? Any questions related with you want me to show it in SPSS, this numerical data single group? No, I don't think so. Dr. Azamat maybe can show you in the practical sessions.
Yeah.
Huh? Maybe, Dr. Azamat, can you?
Yes, I can show during the practical
It
session.
is very easy. Analyze, compare means, compare means, and one sample t-test. You see it is there, one sample t-test. From this menu, it is done in the SPSS. Okay, that much is enough for this week. See you next week, guys.
Thank you, Hocam. See you.
Thank you, Professor.
Take care.